So you just completed your Milankovitch cycles notes and started looking at the changes that have occurred in the past and still occur today between the Earth and the Sun's relationship. And the reason why these are so important is they help us explain why that 800,000 year graph had that increase and decrease without a human impact. And so as these changes happened, we see in the data record, in the ice record and the rock record, that there's been times of growth and times of melt for ice. And it's these Milankovitch cycles that really help explain that. Because as these changes occur in the Earth and the Sun, the amount of sunlight hitting Earth varies. So when the Earth is getting more sun, the Arctic ice melts, and when the Earth gets less direct sunlight, the Arctic ice then can grow. And so again, that helps us explain this variance we've seen over the last 800,000 years. So let's look at our summary questions that we want to tackle this morning. The first one here is, what are the three Milankovitch cycles? So what are the three things that change, right? The first one you heard Mr. Graybo talking about was tilt of the Earth. So that tilt, either more towards the sun or less towards the sun, can change how much solar energy is hitting those poles, therefore more melting or more cooling. So obviously when it's tipped more towards the sun, that's when the ice melts. The next one we heard about was change in orbit shape. So we saw it fluctuate between this oval or ellipse and more circular. And we saw that when it was more circular, that was a more consistent type of season. And so we didn't see as much change in the ice as we do with the ellipse, right? When we get times where we're closer towards the sun, that gives us more heat, more solar energy, more melting. And the final one here, kind of the trickiest one, this one is called the wobble. And what that's changing is the direction of tilt. So in different seasons we saw, or different times of the year, we saw the Earth tilt towards or away. And so what each one of these is changing is the amount of direct sunlight, right? Either more sunlight or less sunlight, therefore having an impact on the amount of ice that stays or the amount of ice that melts. And so here, in your own words, explain how each of the cycles is impacted by sunlight. So you could talk about more tilt or less tilt and what that does. Really try to focus your points here on the poles. So kind of pick one extreme and tell us about it. So more tilt does this, or less tilt does this. Circular, we see this. Orbital, we see, or elliptical, we see this. And what is the wobble changing? And I kind of explained those when we were writing these in, so you could always just rewind and get some help there. So number 4, how do Milankovitch cycles help explain the natural change in Earth's climate? Well, that's what we were talking about. When we're seeing these changes, they're either getting more or less sunlight, and obviously more sunlight impacts the temperature to be warmer, and less sunlight impacts it to be cooler. So that fluctuation in amount of sun explains why we saw this graph fluctuate like this without people. Now, can Milankovitch cycles explain what we're seeing today? Again, what we're seeing today is this temperature increasing and CO2 increasing. Currently, those levels are higher than we've ever seen before, right? The graph we looked at in the past went up to 400 parts per million, and we know in the past that CO2 kind of maxed out at 300. So Milankovitch cycles have never caused that huge spike before. So the answer is no. They cannot explain that current rise in temperatures. It's because of excess CO2 going back to carbon cycle because of those two phases in the cycle that we impact the most.